So in this section, which is the last section of chapter 1, that's textbook section 1.7 to 1.8. First, we're going to discuss about most of the things we already said it. We described the core DBMS functions, which I think we said much of it already. So for chapter 1 doesn't go, chapter 1, I would say, as I said earlier, it's more like terminology and definitions. We are not doing much here. We just want to know what is database, what are some of the functions, why we need it, what are some of the terminology associated with it. In process of that also, we discuss about the historical aspect, how we store data traditionally from way back 60s or something, from manual to file system to DBMS. So that's all in chapter 1. Then lastly, that's what we can call. If you're interested in database career, they will tell us few things. The textbook tells us few things where our interest can be. So yes, first thing we mentioned here, what is a database? Now, what is a system? See, when we see a system, for example, transit system or banking system, a system always consists of many things, not one unit. So when we talk about even computer system, we mention both the hardware and the software together. Everything is a system together because they all have to work together for the system to work. So here we say the complete ecosystem supporting database usage. All the hardwares involving, the softwares are involving. If no data, no computation. Computer always need data. It doesn't matter what you are. Even if I want to find the sum of two numbers, I still need the data of two numbers in order to find the sum. So we need data. And also we have to have the process or the procedure, how we do it. And of course, people do it. So a typical ecosystem that support database usage are everything here. Everything is true. So that's all we can say here. And sometimes go beyond just the DBMS software, as we said earlier. Yeah. Here we are talking about the whole system, the whole system. So here we can say, or maybe we can just say that it's not isolation. So a database does not operate in isolation. We must have many hardware, software, people, data, process, everything. So even the most advanced database management system depends on physical infrastructure also, the hardware. Also policies. If we implement a security and we don't have a good policy, then the security is irrelevant. And of course, people roles, or let me say human roles, human, Human, human roles play. So will be, I will use the term holistic view. The holistic view is essential for what? Understanding the database. Database failures, performance issues, security breaches, etc., etc. Yeah. So what are the major components, as we said? Hardware, software, data, procedure, people. Today, network is important. Most of us even buy a computer because of network, internet, or something. Communication infrastructure also play major parts on it also. Yeah. As we said earlier, a strong database security will be useless if the procedure are poorly defined or people are not trained or the users are not trained. So that's why procedure, people, everything must. So, okay, so let's keep going. So first we start with the hardware component, and I think I won't stay too long here. So hopefully, if it's a client networking system, client server, then of course we may have the servers on premises, or it's a cloud base if we subscribe for it, etc. So here we talk about the hardware, can be servers. Of course, we need the storage, and it's SSD or HDD or solid state or hardware, in any kind of storage. Also, of course, we have backup and recovery system. We have the server, so we need the client source or the end users access section. So this will be a typical, and also I think the hardware can be more than this. But I'll say these are the major ones. Even within the network, we don't want to mention by network card, that's a NIC card or the router, we need routers, etc. for the networks. But I would say, yeah, hardware. Also, the software aspect, number one, of course, is the operating system. Without operating system, computer is useless. So we need operating system. Then the DBMS is application software, so you work on top of the operating system. Then it have utility program, etc. So this all will be. So this is more or less 101 hardware software introduction. So we're not going to stay long because of time. Again, as usual, if you have a question, you can just speak. I mean, yeah, speak or you can ask. So I'll go a quick, not quick, but yeah. Okay, data is the core resources, so we need data. Yeah, data can be, for if it's relational tables, example records, the fields. We need metadata. This is data by the data as we mentioned earlier. It can be the description of the table or the table content like foreign key, secondary key, or explain the constraints, etc. Indices and constraints, yeah, these are all for our database management system, the software performance, improve the performance. Logs and also audit trace, etc. Again, we will discuss all this. It depends on the topic that we follow in the future. Procedures, I will just say the rules, that's it. Rules, instructions for database design, etc. Backup, security, etc. This will be documented. People in the database, well, can be a lot. Ordinary end user, the technicians or engineers or database administrators, designers, developers, end users. If we have data analysis architect, it depends on the infrastructure, the company organization infrastructure. So what is a database management system? We gave this definition earlier, so very quick, software that manages databases, that's it. And also it acts as interface between the user and the actual physical data, also applications, etc. We also discussed about the core database management system functions. One of them, data storage, access, transaction management, security, concurrency for multi-users, etc. Yeah. Oh, let's wait for a few seconds if any question. Okay. Data definition and manipulation. So here we will discuss this more actually from chapter 7. As we said earlier, the SQL consists of three parts. The first is the data definition language. This is where we can use a command like create to create a database object. Common database object always is the table. We can create a view, etc. Alter, so we can use the alter command to change something. Drop, if we want to drop something like remove or delete. But we have now, for example, we can have a command for delete. Maybe delete with, if I want to delete a table or I want to delete the content of the table, it's two different command. Two different work. I have the table. I don't need the table. So I will take all the table out. Or I have a table, but I want to take only the one field out. Let's say the last name, I don't need it. So there's a different way. So again, I won't go detailed about drop and delete is different options. Update is these are all the command we'll see. Way from chapter 7, we will start to see them. Then we have a structured access to data. I would say the data this year, data control language, which is more for the privileges, saving, like we use the command commit. Now, if we're using Oracle, it's almost same as MySQL. Sometimes there's a slight difference. SQL have different dialects. Even with the Microsoft server, SQL server. It's almost the same. So it's easy. If you know Oracle, it's easy to know the others. Yeah. Just small differences. And we'll talk about that in the future. Okay, so this is something we're going to talk, as I said earlier, the acid properties. So we're going to discuss what is atomicity, consistency, isolation, durability. Very important. This prevents partial updates. Also, transaction ensure data integrity. As we say when we talk about consistency, inconsistency, two people want to buy the same thing. The difference is only 1 nanosecond, maybe not one, 100, just small. It's so quick. Will both of them buy the same thing? No. This is where I say do good job or transaction management. But oh, I forget. Sorry. So we are not going to cover this chapter because I think it's chapter 12. Is it 12 or 11? So, but again, if we'll talk a little bit about them, but to talk really about transaction management, there's a chapter for that. Also, concurrency control, there's a chapter for that also. The idea of concurrency is like parallelism. Multiple users accessing data simultaneously. Two or more people doing the same thing at this, trying to do access something at the yeah. So we have to be careful, prevent loss update, dirty reads. Yeah, we'll discuss this in the future also. Backup and recovery, we are not going to talk much about that. But what it does, that's what it said here. For hardware failure, software crashes, we can, if we have a backup, good to go. We're good to go. Let's wait for a few seconds, see if any question. I don't even know my time, man. Let's have a special I put off my cell phone, man. Let me put it on. Oh, good to go. We have like 7 minutes left. We almost finished. At least we have to finish chapter 1. Again, the reason why we can't finish 2 chapters, we spend almost 1 hour in the syllabus a lot, so that's why. So hopefully next week we can cover 2 chapters for sure. So security and authorization also, we will discuss about this more detail. But these are a few examples. Of course, authentication is one of the number one layer of security. If I want to enter system, user ID, password. From there, do I have the permission to look at some specific file or not? Then permission. We have to give the privilege, etc. Then we have what we call the role-based security and data encryption also concept. We'll see this in the future also. Traditional database management normally focus on what we have, which is true. Hardware maintenance, data storage efficiency, manual administration. This is way back before cloud system networking. But today, we'll see the example. Networking is important also, a cloud system, etc. Yeah. Let's wait for a few seconds if any question. Okay, let's keep going. So modern database, so see the first thing, cloud database. Automation also. Scalability because of big data analytics, big data, the 5 Vs. Availability also higher. So yeah, we move more forward. And unfortunately, we won't go through most of this material because there are different chapters altogether. And the section of the textbook have advanced database, some money. So we're not going to discuss more. If time permit, we may say a little bit. Now, what are the new responsibilities of a database professional? Performance tuning. We also have security, disaster recovery planning, capacity planning, sporting analytics, and business intelligence tools. Even today, we even have a data mining analytics tools in most, even Oracle database. They come with data analytics tools. So I said, modern database professional, we must have the ideas idea, yeah. We have not idea, sorry. We must have the knowledge in analytics also. The tool is given for us for free. If you have Oracle, you can see. Okay, so no question. Automation and other tools. Some systems have automated backup, so we don't have to do it ourselves. Self-tuning databases is automated too. Monitoring dashboard, all these are new features, latest features in our modern computer systems. Yeah. The data governance are here now. We follow the state rules. So privacy laws, regulatory, data ownership, stewardship, and also ethical issues also. So why database scale matter? Well, they say data driven, the data drives or drives decision making. It's a marketable field, database power, business system, And actually, if you're a data miner, even data analytics, and your skill is building models, you see it's good to have the idea of a database too. Yeah, so I think very important. Again, because of time, let's move a little bit faster. Not faster, but let's again, as I said, if you have questions, you can speak quick. So these are some of the few fields, and I think I'll move forward. Database administrator, etc., data analysis, all this. And they talk about some technical skill. SQL proficiency is important. If you have a security background too, is very important. Yeah, indexing and performance tuning, which is part of the database knowledge, which even our textbook cover some. And tools and technologies to know, we should know relational database management platform. Today, we have so many data, so no SQL is very important. Also crowd, very important. Crowd database, no SQL. Visualization tool is very important, reporting also. Professional soft skill, well, communication with stakeholders, documentation skill, team collaboration, and also ethics responsibilities. Certification, well, we have vendor certifications. I think Oracle is one of the famous, I won't even say famous, one of the earlier database administrator certification, one of the first. This is way back early 2000, no, not even 2000, before 2000. Oracle is one of the major database systems that came out first with the certification. So there's a couple of them certification online. Course connection. So in this course, well, I would say database fundamentals surely will know since we're going to cover at least up to chapter 9. Practical SQL skills, we will surely know it very well. Design and management concept, we will study as much as we can. And that will be the foundation for advanced database topics. Like when we talk about transaction management, concurrency, BI integrated with non-SQL, I say Mango or Mongo, yeah. But this will be a foundation for that. This class will be the foundation for the rest. So to summarize chapter 1, uh, in general, the whole chapter is here. We discuss about what is a database first, database management system. We also discuss about the historical aspect and a lot of theories around terminologies. Also, we went through some terminologies, theory. Yeah, I mean to say definitions. We saw some definitions also, and the terminologies. So this will be our conclusion today, and we made the time. It's exactly 5:40 now. And I already called the attendance. If in case some of you came late, you can let me know. Then I check the attendance. If not, then we see next week. Surely next week we are going to cover, if not 3 chapters, at least 2 chapters. But we'll catch up. So if no question, then again, see everybody next week. 1.2. I hope Nigel they finish. Nigel, they were able to do it. Thank you. I have 20 minutes to it now. Then I'll start another class. I don't think it's to do that. That way. Oh, I need to try. When I start this, there's a have only one hour to take it. That I'm looking 3 hours. The way teach you. Oh, that's good. Since I'm thinking, I think so. So, since I will. You come and look. Yesterday I received
We got a new ID.
permit.
Oh,
The permit is for 5 years. It will expire. I got it to my 24th.
1,000.
I got it 24 December to 2025. It was expire 23rd December.
Nice.
So, yeah. And if you gotta get yours, man. But I wait for this semester over. Dun, 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 dun. Damn, 10 minutes to eat, man. Yeah.
Nothing for you in the mailbox from Nico.
Okay, so I think we can start now. So again, today's our first day. So the first thing we're going to do is to go through the syllabus and items inside the classroom. Items inside the classroom first. Okay, so I'll start with the syllabus first. Yeah, sure. Yeah. Oh, no, sorry. And this is the type of class. Yeah. Wait 1 second. I want to get the slides for lectures. Database. CS is 20, chapter 1. Okay, so we can start now. Again, make sure my mic is on. My speaker is high. If you speak, I can hear you. Okay, so again, today is, as we said, today is our first day. So the first thing we're going to do, excuse me, is to go through the syllabus. So this is a CS 20 class named Software System Design, sometimes called Software Engineering. So again, my name is Charles Edeki, and my email address is here, cadeke@moro.u.edu. The best way to contact me is by email, or you can also use the message tool. When I say message tool, I made the two message to here. Normally, if you send an email by the message, I will get, or if you send any message by the message I'll get the notification on my email. So either way, it's okay. Yeah. And the course information again. Okay, first, my office hour is by appointment. So normally, the way I go by the office hour is that if you have a question, first I would say let's try by email. So you send me the question. If I can answer the question by email, that's great. If not, I'll look at the question if telephone will be okay. Sometimes we get a question from final project, and the best way to explain this or the quickest way is by using Zoom or collaborators with what we are doing now with the class, with the student. Yes, then that's the last option. It depends on the question. If the question requires that we have to see some document together and discuss it, or problem solving, we need to see it and discuss it, then we will set office our appointment. My appointment day is any day, any time on Friday. If there'll be any office hour, it will be only Friday. Friday, I don't have no class to teach. Sunday, it's a holiday. It's a resting day. Saturday, I have some. So yeah, so Fridays, office hour is okay. Now, this class, we're mostly going to meet online, exception of 3 times for the whole semester, we'll meet on campus. So if we meet on campus, this is the room number. So this course, our residency will be in Bronze. Yeah, Bronze. And one thing is that I don't know when the residency will take place. I don't have no information yet. So when we have it, surely we should have it a week or 2 weeks before the residency. Sometimes if they post it, you should be on the website somewhere. But I'll look for it, and then if I get it, I'll post it in the classroom. So this class, as we can see today, we meet on Wednesdays. We start from 6 p.m. to 9 p.m. So the course description for this course is a software engineering. And a software engineering is quite different from programming, but at the same time, I would say the programming language will be the tool that we have to use to develop a software. But the prerequisite for this class is none. So, yeah, we're going to follow the textbook and we'll go through that section. But to summarize everything, this class we are going to learn the techniques or the methodology that we can use to solve software problem or to develop a software. That's why it's called engineering. So we are going to use some scientific or some method to develop a software. Actually, very important to design. The design part is very important. So from beginning now to somewhere around chapter 6 or so, all we learn is about design. So we start with like requirement analysis, what is functional requirement, non-functional requirement. Then we talk about different design approaches, agile method or waterfall. Waterfall is the classical method. That's the first method in software development process, life cycle process. So it's like you start with requirement, design, implementation, testing. If everything is good, deploy, put the software in operation. Then the last option is maintenance. So we discuss all this. So that even when we look at the textbook, this is all about the course, the all the steps. So first we're going to learn the chapter 1 today. We're just going to talk about general concept, a lot of terminology, a lot of definition, methodology. Then we move on to the modeling. This is where requirement concept will come with other issues. Then we'll move to design. Then design method, so many. So we talk about scrolls, agile, this and that. So we get all together. Actually, the steps are here. So student will learn overview of programming concept, system analysis and design. Normally, system analysis and design is the requirement and design phases, including project management. Very important because software development process is about project. We are managing a project. Software development is a project. So we will see that in a syllabus later on. The chapters we have to. The book is very big. It's over 25 chapters or so. 20, yeah, 25. There's no way we can cover 25 chapters in 14 weeks. That means we have to cover 2 chapters every day. Not even chapter 1 only for today. So we'll see the syllabus. They mention some syllabus. The chapters that we need to cover is all mentioned here. And that's where we're going to focus everything. Now, if time permit and we have time, then we can. No, I won't, we will not have time. You will see, you will not have time. But I'm just saying that because even the chapters they gave us, we cannot cover all of them. But we'll talk about that. So that is the whole course description. We'll focus, I think the first 6 chapters is most important. We'll talk about the steps in developing software development life cycle, planning, and then requirement, design, implementation, testing, deployment, maintenance. Yeah, those are order. Then later we have some chapters that talk about survivability, reuse software, those advanced topics. Some of them are not going to. We can cover them. So as we mentioned earlier, prerequisite in this course is none. So you don't have to have any programming language background. But if you have a programming language background, it's a good thing. In a project, which we will discuss that one later, some students do the project, but in majority of the students, the final project is implementation. They design and develop a software. It can be library management system, inventory system, patient system. If you're into data mining, data science, pattern recognition, it can be in a modeling system, supervised, unsupervised, reinforcement learning, and the only thing the final project we to discuss, we will start with the proposal, then from there we move forward. So if the proposal is approved, then we move forward from there. Yeah. So the the textbook is very good. They give to us already. So we are all of us have access to the textbook. We have the Vital Source textbook. But also, let me see if I no, I didn't. Oh, yes, right here. Also, for example, me in my case, I don't like reading books in a Vital Source. So I went online a couple of semesters ago. It's like 10th edition. I know it's been a couple of years, but the materials are almost software engineering method. It doesn't change. It doesn't change. Actually, they increase it. I mean, what is increase? They improve it. They add more topics. So I'll say the first 12 chapters of this book is any version is the same. It's the same. So I use this one. I prefer this than be on the internet, Vital Source and all those. So it's the same book. And you can see the topics. Normally, of course, the first thing I will look is the table of content. The sections, everything is the same. It's the same up to some chapter, at least up to chapter 9. From here going is where we are going to skip some of the chapters. They will tell us what we should cover, what we should do. So actually, 10, 11, 12, 13, we are not going to cover up to 14 no. So the system dependability and security, we skip all the chapters there. Then part 3, we are going to cover. Here they give us, again, we'll see the syllabus. They gave us option to cover some of them. Then the project management, which is the last section, very important. So I'll even start covering this earlier before this section, before I advance this section. No, sorry. No, start from 15. Oh, yeah, 15. See, I don't even know why. Yeah, this section. Yeah, this section is not in the syllabus. So, yeah. So let's keep going with the syllabus. Oh, what's the syllabus? Okay. So that's the course material again, 25 chapters, a lot. And then the final grade activity, this is what we are going to have. So homework assignment, 20%. Exam, we're going to have 2 exams, 30%. Then we have final project 30. Then final exams is 20%. Total should give us 100%. Yeah, so this is the same. So today, surely we have to do our best to finish chapter 1. Even if we don't finish chapter 1, the 2 objective is all we need. The last objective is just a case study, save us some software failure and successful few. I think they gave us like 4 case studies. Yeah, but the materials and also this section we can see this is like beginning and introduction. So there's no specific methodology or anything here. It just generally we talk about the software development process, the whole concept. So most of the materials we cover here is what we are going to start covering from week 2 down. So week 2, that's when next week, chapter 2, that's when we start with the process models. And then we move to the agile. For some reason, this book start agile early. Then we have first exam. Then it's like a waterfall model. We start with the requirement engineering. Requirement, we have functional, non-functional, how we get the requirement, elicitation, validation, change, etc. We cover this. So we can see that each week we cover 1 chapter all the way to chapter 9, which will be week 11 after the meeting. Week 11. Then the semester is getting to an end. All of a sudden, week 12, they say we should choose any topic, any chapter here. That's what I was saying previously. 15, 16, 17, 18, 21. The highest I can cover is 2. Even if we are going to cover 2 chapters, it means we even have to squeeze the time in. It's difficult, but we'll see. We're not going to rush. We just go with the flow. If we cover, fine. If we don't cover, at least we cover one. Then when it comes to the project management, same thing. But what happens is that sometimes it depends. Today, because of the syllabus, I'm surely one chapter. Chapter two, let's say if we finish chapter two, we can just move on to chapter three. We don't have to say, okay, go home because the book said week three, we start chapter three. No. So we just move on. Then hopefully this option here is very flexible. We can cover as many, if we can cover all the four, fine, according to the department. If we can cover two, fine, but at least we have to cover one. So choose one from there. And in project management, also the chapters go in sequential order. So surely I won't go to 25 without covering 22. So I will do 22. Here we can choose which one we want. So it depends. I can do software reuse. It's like it depends. These are more or less like independent chapters. You don't have to know 16 to do 17. You can move any of them. Yeah. So then by week 14, we do so this course have a final project. If I'm not mistaken, this course have final exam. For some reason, they didn't write it. Yeah, there's final exam. But we should know final exams is the last week. Maybe instead of writing final exam, they write final project. Well, I didn't even look. I should have edited. But again, the syllabus come from the school, so the department. So I normally don't. But of course, this normally final exam will be the final week. Final project presentation. Sometimes it depends. We can even get it somewhere around week 12 or 13, not 14, maybe 12, 13, something like that. So it depends how we go. Because normally what I do, I want the final project to be due by week 12 or 13. If the final project due week 14, I have 1 week to read it. It's a lot. Then the final exams is coming. I'll have a lot of grading, and I'm teaching more than one class. So normally all my class, I will say the final project, I always put it in week 13. Sometimes it depends the project content. This course, we can move the final project to even week 12. Why? Because you choose your topic. And then you don't have to know software management in order to do your project. You don't need to know advanced software engineering concerning all that. Even your project, most likely you are not going to discuss about reusability or survivability, maintainability of software, the technique. Most likely you are not going to discuss those issues. The project, mostly if it's a hands-on, you have to know up to, even design pattern, you don't have to, but you have to know at least up to here. But let's say up to week 8 at least, because week 8 we talk about a UML diagram. Very important. UML diagram is software engineering. For example, if you take programming class, they may take only the class diagram. Or if you take a project management class, maybe they will talk about activity diagram. That's it. Activity diagram, that's it. Which is something called a work breakdown structure, WBS diagram. They use what they call a Gantt diagram using Microsoft project software. You can come up with the activity diagram. Yeah, but UML have somewhere around 40 languages. And in software engineering courses, it depends on the textbook content. We have to learn at least 10 of them. So you have to know use case diagram, activity diagram, sequence diagram. It's good because this is the only class that you learn what UML stand for Unified Modeling Language. Modeling. So you model the system. So if I'm designing software, it's very important to have a use case diagram. Use case diagram tell me how users interact with the software. So you set a boundary and you have some over for different users. Let's say I have a library system. The customers, they can only borrow or return. But the manager for the library, it can update the inventory. So this is just a simple example I'll give. Because you have a system, you can get more than 2, 3 different users level. Some users do this, some users will do this. So you know where privileges, everything, you set it. I will not tell a library patronizer or customer, give him access to update the library system. No, you don't work there. So this is where the use case diagram come in. And when you are designing a software, activity diagram, yeah, that will tell you all the activities in sequential order to accomplish your goal. And sometimes we have something called a critical path. You have to do two things at the end. I'm building a house. Well, if I don't have no foundation, I cannot make the roof. But if I have the foundation, I have the structure a little bit. I had a structure already. I can build the roof and the same time, what I can do again, I'm not a, and maybe the same time, uh, maybe the same time build a kitchen. No, kitchen with the roof. Roof have to be there first before kitchen. But what I'm trying to say is that sometimes you design software, you may have two tasks. You can do them in parallel, but you may have some tasks. You have to do the other one first before the second one. So this is where the sequence diagram, activity, everything. So by the time you implement a system, you have already understand everything. With all these models, you know how the system will behave. From these diagrams, we know how the system will behave. Then the inner part is where you even have to come up with a class diagram if you are doing object-oriented programming to implement it. Then class down the other. If it's related to database, then the ERD diagram also will come in, entity relationship. So yeah, so in this course, we're going to talk a lot about the UML, a lot, and design section a lot. So what I'm trying to say is that by week 8, you finish, you can do your final project. You already know all the modeling process, the requirement techniques, then the design implementation in chapter 7. You know the UML diagram, you know the design patterns. We have like a couple of them, like facade and so other, but if you want to use them, fine. Yeah, yeah. Then software testing is very important. Also, we have different type of testing. You can have a unit integration, alpha, beta testing, different type. Yeah, we will discuss that also. Yeah, so that's what I would say about the syllabus. Okay, sorry, no, having fun. So the next section is the attendance. I think most important thing is the grading here. Hopefully, if no question with the grading, then we're good to go. Then these are the topic we explain as much as we can. The first time, we go straight in sequential from chapter 1 to 9. By that time, we almost coming to the end of the semester. Then we see how fast we go, how slow we go. At least we have to pick one here. But if we can do two, perfect. At least we have to pick one here. But if we can do 2, 3, 4, perfect. These two sections is feasible for us. That's how the course is done. There's no way we can do 5 chapters in 3 hours. When from beginning to week 11, we do only one chapter. Then all of a sudden, when we reach the advanced section, we do 5 chapters. No. So just I want to explain this to the class. You may see the syllabus. Please say, Professor, why you didn't teach chapter 21, 18, 17? It's not my fault. You know, that's how the syllabus is designed. I would say chapter 1 will go faster than chapters 15. So why is week 1, they don't put 2 chapters, they put only 1 chapter. So just to make this clear here. Okay, so attendance policy is the school policy, so I'll leave that section for no. So well, let me so that actually let me read the first section sentence. The value of college education depends upon full participation in academic classes. So that's why attendance is very important. Attendance, additional information. Yeah, so this is what the school use. This is straight from the Moro University catalog. So Moro, for example, doesn't have manuals grade, so there's nothing like A manuals, B manuals, etc. So sometimes a student get 89.4. Just in 0.1 to go to A from B plus. So, but that's how the course is designed. I mean, not the course, that's how the college grading scale is in Moro University. Some schools have manuals. By the time you get 89, they even make it A manuals. So here also we talk about responsibility. It is the student responsibility to obtain material assignment, etc. So even if you're absent, make sure. The good news is that we discuss more or less like an online class. We meet like 13, 11, 12 times online, 11 or 12 times online. Only on campus is 3 times. And no, even some of us will not meet on campus at all. Again, don't ask me that why. I don't know the reason why. Also, the residency 3 times I know because we did that always, but I don't know when. So please don't ask. If I get a schedule, I'll post it in the classroom. So yeah, so that's what I can say here. Mostly it's online, and so if you miss a class, just go. You will see. I'll come there when I go to the classroom. Every week we are going to release the week earlier. Like today, we meet. I think I released it the day before yesterday or so. But I'll try to release. For example, week two we meet next week Wednesday. You should see the week two materials, everything by Sunday, by weekend. So sometimes we have class. Previous semester I have a class whereby when I release the week, some students submit their assignment for the week already before the lecture. Well, that's fine. Actually, I like it. If you know the materials already, fine. But unfortunately, we have to follow the syllabus. So even if you know it, I can't skip it. We still have to teach everything from beginning. So what I'm trying to say here is that yes, if you know the assignment, you can submit it before due date. That's perfect. Academic integrity, I'll leave that section. That's what we call the honesty. And that will lead to opposite of honesty is dishonesty. Cheating is not allowed, plagiarism is not allowed. So we can say that Moro University is the same as many universities around the world. Academic is a very, high esteem. It's not a joke. So one thing also unfair advantage. So yeah, unfair advantage. Let me explain that one session. Sometimes for example, if you submit assignment, this is just one example I want to give. If you submit assignment and assignment is due or it's not due, I mean, assignment you submit earlier or due date, it doesn't matter. So that's why when students submit assignment earlier, I normally don't like to grade it. I wait till the due date before I grade. Because if you submit assignment and it's, oh, I forget, I'm supposed to include A, I forget to include A, I did only B and C. If I did not grade it and you did not see your grade, I will tell you do it again. Yeah, you can submit it. Even if I don't want to open the grade book, I'll tell you submit it through the message. I do that. But as soon as I grade it, no submission no more. Because that means I have to regrade it again. I will not grade assignment twice. I will not. I wouldn't do that. Otherwise, that would be unfair advantage. Another students get 90. You want to get 100 and you get maybe 80. Then I open for you, then you get 100. Then I have to open it for all the classes. Everybody that I grade their work and their grade is less than 100, I have to let all of them do it, redo it again to get 100. I already give you feedback and I tell you get 80. And you say you forget something, like I should open it for you. No, I can't do that. But again, if it's not graded, I will surely open it for you. That one say you don't have to ask me. I mean, you don't have to ask twice. Of course, you have to ask me. If you don't ask me, I don't know. If you say, oh, Professor, I didn't, or you can call me any name you want to. I didn't add A or B. Can you open it? Oh, sure. I'll release it for you. Or if I don't want to open it, I'll say just message it for me. Sometimes when I open it for you, I have like it to open for the whole class if it's already due. Yeah. Even if it's already due and I didn't grade it, if you tell me you forget something, I'll open it for you or I'll tell you submit it, even if it's already due. Because I did not grade it, I will accept it. Additional material and grade it for you. But as soon as I grade it, I can't change the grade no more. And especially you see your grade, you see the feedback. Come on, let's be honest here. Another example, presentation is today. You already know 2 weeks ago, or 3 weeks, or even 1 month ago that you do presentation today. Oh, Professor, I'm sick. That's fine. Oh, Professor, I have emergency, my family. That's fine. I will give you time to recover. Possible if we cannot do the presentation no more because the semester is coming to an end, I will give you two options. Do you want me to give you incomplete grade, or can you make a video presentation and submit it so I can grade it for you? Yeah, fine. Now, presentation. Oh, Professor, I can't do it today. Why? Because I didn't prepare. I'll give you 0. You know that we have presentation over a week ago. Why you didn't prepare? Oh, because of this emergency. Okay, I understand. So again, depends how things goes. It's case by case, case by case. Yeah. Myself, I can get sick at any time. You know, hey, nobody in this world tomorrow is guaranteed to nobody. So I understand everything, but no, that's how it is. So yeah, so that's what I would say. But that's why I highlight it. I think that's the only thing unfair advantage here. You do something, I will explain to you nicely because of this, because of that. If you disagree with me, then I have a supervisor. No, you can go chain of command and then report. So that's one. Student evaluation. So at the end of the course, I think that one is traditional. And when you're evaluating me, please be honest. I'll do my best not to talk about politics, not to talk about anything. Even if you talk to me about politics, I'll keep quiet. If you talk to me about Africa or Europe or Asia or Caribbean, I'll keep quiet. I'll try. Sometimes I talk, but I learn not to do that no more. It's not good. So I'll be more into software engineering. So yeah. So the evaluation, be honest. In case I talk about Caribbean or somewhere, yeah, put it on evaluation. When I read it, oh yeah, I forgot, man. Okay, I'll put this in my head. I don't need to talk about politics or this and that no more. Okay, the next one is SIT stand for School of Information. Oh, it's right here. Okay, School of Information. That's our department. Which kind of graduate school say fall under the King's Graduate School? But this is the if you're doing computer science, this is our department mission. I'll leave that section for you. In summarize, I'll tell you that the mission of the department is to make sure they have the possible materials to provide the best high class or world class education to improve everybody professional career or yeah, that's all. And yeah, so yeah, this faculty, yeah, okay, so this is policy. The first policy will be homework turning late is good. I will grade it. But 5 points per calendar day will be deducted. Hopefully we understand that. Calendar day per day. Yeah, let's say like that. Then homework is due on Monday. That is 10 on Wednesday. 3 days, 15 points automatically. Yeah. Now, any work 10 using, some means to get it, some bad means to get it, 0. Everything you do counts. No lowest grade will be dropped. Or let me read this, lowest grade will not be dropped. So there will be no lowest grade drop. Like say we have 5 assignments, drop the lowest grade. No, every day will be counted. And I think that's it for the syllabus. Let's wait for a few seconds, see if any question. Okay, so if no question, let's move forward. Oh, so one thing I forget to mention, with the attendance.
Prof, I have a question.
Yeah, go ahead, please.
You mentioned the project. Are we going to select our own project for the final presentation, or you are going to provide a specific project for us to work on to do the presentation?
Yeah, with the final project, there will be instructions on what we have, the requirement for the project, instructions, there will be instructions. So you have two options. Most of the time, students select their own project. For example, we select a project and as we say, okay, no, this project is not doesn't meet the requirement for this course. Do you want me to give you an example? Then maybe in the feedback I can give you an example of what project to do. But first, yeah, each student have his own opportunity to select any project that he prefers. Since this is a software engineering course, it's kind of it's very widely open. For example, if I'm taking data mining class, I cannot develop a project for let's say library system or inventory system where I'm not going to implement no data mining algorithm, nothing, no machine learning algorithm. It's impossible. So if I'm taking machine learning, if there's a project, they have to be related to machine learning algorithm. But since this course is a software course, for example, you can get a project from any software because data mining software is a software. Actually, I even use the term software. Library system, patient administration system, build a model with Python if you want to do. So the project is your option. You can do a hands-on project or you can do a paperwork project. That's up to you. Again, by the week of fourth or sixth, between fourth, 6 week, we will see the requirement for the proposal, then we will get the idea together hopefully by then. So wait for a few seconds if any more question. If no question, I'm going to close the attend. I'm going to close the syllabus. Now with the attendance, I think I don't know if I mentioned it, but let's maybe mention less than 1 minute. I normally will take the attention. I will take the attendance by after we take a second break or before we take a second break. By then, we should have enough students in the classroom, those who are later here. Because from my past experience, when I take the attendance early, normally I take the attendance, the first thing I do is take attendance. And within 30 minutes, a student may arrive, then maybe I have absent, I have to call the absentees, I have to call absentees maybe 2 or 3 times before the end of the semester. So I want to save all that time for lectures. So today we went through syllabus because first day. And next week we come, we start the class straight, we start the lectures. Whatever we have to do, unless if any question, we answer question, then we go. So right now we finish with the syllabus. And if no question,
Okay.
yeah, go ahead, please.
Yeah, I wanted in connection to the semester project, I wanted to know if we are going to come up with a full-fledged software application or we have to do something like a console application while we are implementing the software engineering technique.
Please, I cannot hear you because you have a noise in the background. If you don't mind to lower the noise, I'll be happy. No, not I'll be happy. It will be nice. Sorry, I'm already a happy person. So if you
Okay,
can lower,
sorry.
I can't hear you well
The
because
background noise. The background noise.
no, it's
So I was asking about the semester project. I was asking if we are going to come up with like a full-fledged application with the front end and everything, or we're going to do something like a console application where we just deal with the maybe a Java program while we are implementing the software engineering technique.
oh, that one is your option. And that one we mentioned for the whole class. For example, I think when we are going through the syllabus, we saw the prerequest. The prerequest said none. And I quite mentioned that since the prerequest is none, I'm expecting that none of us know programming language. But if you know, at least it's good to know at least one programming language. But if you don't know it too, it won't affect you too much in the course. But try to pick up something. So now I can come up with a project. I'm good in Java. We use Java. I can come up with a project. I'm good in Python. Okay, I want to come up with machine learning. No, I want to use a supervised learning algorithm to create a model to do prediction of cancer B. Okay, I'll use Python. I think I know the sklearn. Oh no, I don't know anything about sklearn or scikit-learn. Then I can't use Python. Let me use C++. I'm a old-time school. No, I'm not good in C. Okay, let me use Java then. So now, the reason I'm saying all this is your option. It's the option. So you can use even if you want to use the functional programming language such as Scheme. Scheme is very good for AI applications up to today. Some companies are still, not companies, even some schools are still teaching it, functional programming language. You can even use a JavaScript functional portion to create a simulated system. Everything is up to you. All of them are software. So that's why I mentioned that with this course, software engineering, when it comes to the project, choosing a project, you have so many areas. It's up to you, can choose any. Now, as I think I use that as example. If this is a data science course, well, you can use a scheme language to create a simulated, you have to use a data science algorithm or something to do some, and not data science, I mean machine learning algorithm for data science. So yeah, so with a project, it's up to you, anything. No, I say anything. It's up to you. Any software is good. Now, we have a student who don't know any programming language we mentioned, from C++ to Java to everything. They don't know anything. So the best option as a student, I'm going to write a paper based on the knowledge of this course. That's also fine. So we have some students, they write paper. We have some students, they do hands-on implementation. So the option is up to you. Let's wait for a few seconds if any other question.
All right. Thank you very much.
Yeah, that's fine. Let's wait a few seconds if any other question. The syllabus. Okay, so if no question, we can, excuse me. Oh, it's almost 1 hour, 6:46. So let me see. I think I posted a slide here. I divide the slide into 3 sections, and I will explain the reason why I do that. Oh no, I didn't post. Okay, so right now we have the original, which is okay. The same content, nothing changed. So this is the original slide from that. Actually, we can see the textbook. So this is the slide that came with the textbook. But I edited the slide and also had some more example to make it. This is 2014, long time. So we had some few things. So when I finish, I'm going to post the slide. I didn't even know I didn't post it. So that's the slide that I was opening here. So I have them here. It's 3. So it's part 1, part 2, part 3. So it's not too long, but so what I'm going to do is that I know unless the class want to take a break, other than that, I want to finish the first slide and we take a short break before we take our first break. So you'll see the slide will say Unit 1, Part 1, which is the first section of the slide. Sometimes also in the objective, I will add a section. I didn't add this section because why? Because it's very straightforward. Well, let me explain this so that in the future, when you see the slide, you will understand. Now, this is the database class. Yeah, so for example, when I'm preparing the slide, you can see I said I have 3 parts for chapter 1. The reason why, because we have 3 sections here. So slide 1, I'll say unit 1, part 1, which means 1.1, unit 1, part 2. So the same thing, when you go to chapter 2, I have 4 parts. This gave me a chance to add more examples. So part 1, part 2, part 3, part 4. So part 4 is only for process improvement. And when you look, it's the same thing here, process improvement. Part 3 is talk about coping with change. So when you look at the original slides, maybe they have only 5 to 10, 12 slides for coping with change. But my slide will be like 20 or 30 slides. It's had some examples also online, do some research, get some materials in. So that's what I was saying. So for example, next week, I open 4 chapter, 4 slides. It's okay. They are all chapter 2. And the name of the slide, say you will see that is each section is the name of the slide. Yeah. So just to explain it. So for example, part 1, you can see I name it here, professional software development, software engineering. And if we go here, professional software development, I will add the software engineer, but I'll try to name it as that section. Yeah, so I don't even have to put the objective. Sometimes I put the objective, but I don't have to. Okay, so if no question, let's go straight forward. We're going to finish this, then we take our first break. Yeah. So I was recording this. It's a long time.